example I will give you. So let me take, I am saying that density of petrol is something, and let me take density of diesel is different. So now if you notice it, all of you, if I open one petrol tank and a diesel tank, so you can feel the smell of petrol or diesel faster. Anybody can tell? You will feel the petrol smell is faster or diesel smell is faster. Anybody?
Petrol.
All of you?
Sir, petrol.
Petrol.
Yes, please.
Petrol.
Petrol.
Petrol smell. Clear, everybody? Because what is the reason? Because petrol is having less denser than diesel. So who will diffuses more faster? Who will convert into gaseous state more faster? All of you. So let me try petrol. Understand? So I can say, you can take who is more volatile in nature, petrol or diesel? Petrol or diesel? Petrol. Clear? That is what. Okay, write it. Right. When we open the tank of petrol and diesel simultaneously, example. When we open the petrol and diesel, when we open the tanks of petrol and diesel, you should not forget this. Clear, everybody? Diesel simultaneously. Kishore, Purima, Kishore. We smell whom first? We smell petrol faster or diesel faster?
Petrol.
Petrol faster than diesel. Okay? Because, Vaira, what is the reason? Because petrol is having what? Petrol is more volatile or less volatile?
More volatile.
More volatile.
More volatile than diesel. So that is what. So till here, combine this all the three properties and tell me the statement. Anybody, let me see who is that much capable. I want statement, single statement from all these three properties. Yes, Mr. Lingesh, Sanjay, you want to say fluid means?
It can flow easily.
That's all. Combine all the three statements and tell me three properties, any one statements. So I can say from this all the three properties, I will give you a chance. Anybody can tell me what is the properties of one single statement about liquids. I will say. So hence I can say that by seeing the no fixed shape, fixed volume, fluidity, I will say that liquids have a definite volume, but no definite shape, and they show what they will show? Fluidity. Is it yes or no, guys? All of you? They will show
Yes,
the
sir.
fluidity. That is what the statement I can form it. So from this, all the three properties I can say common statement, single statement to remember all three properties. What is that? All of you. Liquids have a, please respond. Definite volume, but no definite
Shape.
yeah, no definite shape, and they show what? All of you.
Fluidity.
Yeah.
Fluidity.
It shows
Fluidity. That is what you have to remember. Is it clear, everybody? All of you?
Yes, sir.
Okay. So
Yes,
next, write it. So if you understand this, then we have to proceed with the next one. That is what, where our textbook, they have given one activity to see these properties. That activity I hope you people can do very easily. So that is what we have to take: water, cooking oil, milk, juice, and a cool drink. So any cool drink you can take. So different containers you can take it. So you can see, take containers of different shapes. So spill the water. They are saying containers of different shapes. Put 50 ml of mark on these containers using a measuring cylinder from the laboratory. So then what will happen if these liquids are split on the floor? So you can see, measure 50 ml of any one liquid and transfer it into different containers one by one. Does the volume remains the same? They are asking. Is the volume remains same every 50 ml? I'll take 50 ml of water, 50 ml of cooking oil, 50 ml of milk, 50 ml of juice, and a 50 ml of cool drink. Does the volume remain same or not? Everybody? Yes, please.
Yes, sir.
Yes,
Volume is remains fixed, but I am putting into the different shapes. So what is the shape of that liquid? Is it same? Everybody?
No,
No.
No. Clear?
Yes, sir.
That is, you should understand. Next, does the volume remains the same? Yes. But does the shape of the liquid remains the same? Is it, everybody? No,
No,
because
sir.
different shapes we are putting. The container shape, based upon the shape of the container, it will be having. So what is the conclusion I can make? The liquids have fixed volume, but their shape is not. But the shape is not
Finished shape.
next.
Not
When you pour
definite.
these liquids from one container into another, does it flow easily? Is it, they will flow
Yes,
easily or not?
Yes, sir.
Yes.
Yes, sir.
So the liquids can flow from higher places to
Lower places.
lower
lower
places.
places.
Yes, they can flow easily. That is what I can say. Next, I can say, all of you observe. Next, they are saying, we observe that liquids have no fixed shape but have a fixed volume, and they will take up the shape of the container in which they are kept, and liquids can flow and change their shape. So they are not rigid, but they are not rigid. But who is rigid, everybody? Who is rigid? Already we studied. Who is rigid? Solids are
Solid.
rigid. Understanding? But they are not rigid. That is why they can be called, what we used to call, everybody?
Fluid.
They can be
Fluid.
called as
Fluid.
fluid. So that is what you remember. Is it okay, guys? Everybody understood or not? All of you? So
Yes, sir.
we can prove all the three properties of matter. Now, sorry, that is what liquids. Next property. As I am saying, high density means more volatile or less volatile? High density means,
More
everybody.
volatile.
High density means more volatile.
Less volatile.
Very bad. High density means
Less
less
volatile.
volatile or more volatile, guys? Everybody?
Less volatile.
Less volatile.
Less volatile. Understanding? And low density means what?
More
More
volatile.
volatile.
Low volatile.
More volatile.
Understanding? Less, that is what? Low density, more volatile. High density, less volatile. So that is what you have to remember. So we should take. Now you tell me, is it all the liquids having the same density or different density? Everybody?
Same
Different
density.
density.
Okay, that is the fourth property of liquid. Now you tell me, compared to solids, liquids having less density or more density compared to solids? Generally compared to solids, they have more density or less density? Generally,
Less density.
less density. Understanding? So because of what reason? Particles are far away or closer to each other like solids? Everybody?
Far away.
They
Far
are
away.
little
They are
far
mostly
away, understanding, from each other. That is what. So right. Generally, the liquids have lesser density than solids, but have high density as compared to whom? Everybody? High density as compared to whom? All of you?
Gas.
Yeah, density as compared to gases. That is what you have to remember. So if you take the liquid which is having a maximum density, that is what we can say semi-solid. What is it called as? The metal, one and only liquid metal. Everybody?
Mercury.
Understanding?
Mercury.
If you take the mercury, we'll represent with the Hg. The density of the liquid, you can see this maximum density of this mercury, that is what liquid, this is equals to 1200 kilogram per cubic meter. Do you all understand, everybody? What is that? 13,200 kilogram per cubic meter. Or now I will say, understanding, 13.2 gram per cubic centimeter, or I will represent per liter, as it is liquids. Liquids will measure in what? Sanjay, liquids will measure in what? Liters only. Right or wrong?
Liters.
If you take the liters, I will say 13.2. All of you remember, kilogram per liter. Now you understand what I am saying? 13.2 kilogram per what, guys?
Cubic.
Kilogram per liter. Understand, Amma? Agalya, Shivani, clear? That is what you have to remember. So all of you, now I will introduce a new relation. Remember, 1 liter is equals to 10 power minus 3. Sorry. Yeah, 1 cubic meter equals to 10 power minus 3 cubic meter. Or 1 cubic meter is equals to 10 power 3 liters. Sorry, everybody clear? 1 cubic meter equals to how many liters? All of you?
10 minus 3.
Yes, please. 10 power 1 cubic meter equals to how many liters? All of you?
10
10 power
cubic
3
10 power 3
means 1000 liters. Sir, what do you mean by that? I will draw here. Observe. I will take a cube. Suppose Mr. Sam is prepared a cube. Each side is having 1 meter. How much, Sam? Each side is having 1 meter. Understanding? So this much big cube you have been taken. So in that, how much liquid I can fill? How many liters? 1 meter, 1 meter, and 1 meter. So how much fluid I can fill, guys? Everybody. 1 meter into 1 meter into 1 meter. So that volume of the cube is equals to 1 cubic meter. So 1 cubic meter means here how much liquid I can fill? Everybody. 1000 liters of liquid I can fill. That is what 1 cubic meter is equals to how many liters? All of you respond.
1000 liters.
1000 liter.
Understand, Nivedan? Purima?
Yes, sir.
Yes, very good. So please do it. Any doubt, anybody can ask me. Okay? Yes. Next. Understood, girls? Sangamitrai, Hasini? No response at all.
Yes, sir.
You can write Kishore, 1000 liters also you can write it, nothing wrong. Sir, you might be ask me, sir, how to convert this kilogram cubic meter to kilogram liter? Shall I do it or not? If you want, I will do it. Otherwise, I will do it. So I am saying 13,200 kilogram per cubic meter. Yes or no? Now, I will write 13,200 into 1 kilogram divided by cubic meter means 1000 liters. Yes or no, guys? All of you. So 1000 means divided by 1000. That's all. So 1200 divided, 13,200 divided by 1000 kilogram per liter. So means 3 years before it will go dot. Is it right or wrong? 13.2 kilogram per liter. Is it right or wrong, Lingesh? Sailesh? All of you? Understood? Understood, Amma, how to convert it? Please respond. Don't know means I will say it.
Sir,
That is what
Yes, sir.
kilogram per cubic meter. How to read this one? Kilogram per cubic meter to kilogram per liter. That is what you have to remember. So this is the fourth property. Next, fifth property. All of you write. Fifth property. Kinetic energy. So tell me, kinetic energy compared to solids more or less, and compared to gases less or more? As it everybody. Yes. Compared to solids.
Has more kinetic energy
Yeah,
compared to
compared to
More
solids, more kinetic energy, because the force of attraction weaker or stronger compared to solids. Everybody, the force of
Weaker.
attraction. All of you, force of attraction
Weaker.
weaker. That is what. So right, the particles of liquids have high kinetic energy. High kinetic energy as compared to solids, because the force of attraction is comparatively weaker or stronger? All of you. Comparatively weaker. Clear, everybody? So that they will move easily. Is it right or wrong? But they will move within a liquid or out of the liquid? Everybody?
within the liquid.
Within the liquid.
Within the
That is
liquid.
what you have to remember. Clear, guys? Everybody? Yes? All of you. That is what.
Yes.
Next,
yes, sir.
sixth property. So solids, what is the last property? Can you tell me? Except sublimate products, remaining all, the last property something is there. I taught you. What is that?
Diffusion.
Diffusion. Now tell me, of course, other than solids also. Now diffusion in liquids, more than solids or more than less than solids? I want to know. For example, I will write something on blackboard with my chalk piece, and I will put 1 liter petrol in outside. So who will diffuse more faster? Petrol into air or blackboard chalk into board? Who will be diffuses more faster? Yes, please.
Petrol.
Petrol. Understanding? Because the petrol is a liquid, so easily it can diffuses into the air. That is what do you mean by diffusion? I already told you. What do you mean by diffusion? High concentration to high
Low
concentration to low concentration. Okay.
Concentration.
So that is what we have to write. Transferring of everything from high concentration to low concentration. Okay. So right. So the rate of diffusion in liquids faster or slower than solids? Everybody. All of you.
Faster than solids.
Faster than solids. Right.
Faster.
Yes. The rate of diffusion in liquids generally, please remember, generally it is liquids is faster as yes Sanjay, correct Sanjay, very good. But here gases are not diffusing Sanjay, liquids are diffusing. That is what faster as compared to solids, as compared to solids. Clear everybody? All of you? So for example, let me take. How many of you know alcohol? Alcohol terima, drinking alcohol, whatever it is. So you can take here. So I will say, why this diffusion is more faster? Anybody can tell me? Because you can take particles are, what is the force of attraction? Less or more in liquids compared to solids? Everybody?
Less.
Less. So that they'll move freely. And one more time. Now I'll give you two liquids, volatile liquid and non-volatile liquid. Who is having greater diffusion? Anybody? Volatile or non-volatile?
Volatile.
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 So that is what. So if I'll give the alcohol, or we can say spirit. So if I give spirit, spirit is more diffusion than water or less diffusion? Yes, please. All of you. More volatile than water. So that who is diffusing rate is faster? Spirit or water? Everybody.
Spirit.
Spirit. Understand, Amma? Please respond, everybody. Clear?
Sir.
Yes. That is what you have to remember. Okay. So that is what. The more volatile the liquid, faster will be the rate of diffusion. Write it. More important point. The more volatile the liquid, faster will be the rate of diffusion. Is it okay, guys? Clear? So can you give me the examples of volatile liquids? What is the known examples of volatile liquids? Of course, water is also considered as a volatile, but compared to alcohol, water is a less volatile or more volatile? Yes, please. Compared to alcohol, water is a less volatile or more volatile?
Less volatile.
Less volatile. Okay, if you take volatile liquids, if you want it, you can take petrol, spirit. Okay, if you go to chemistry lab, ether, you put in hand, it will evaporate. And acetone, these all are examples of volatile substances. Is it okay, guys? Of course, perfume, Abhiram is saying, perfume is volatile only. Yes, of course. So that is what the things. Now, non-volatile examples. Can you tell me? They are the liquids, but they are the non-volatile. So what is that? Non-volatile
Liquid.
liquids. Of course, even
Water.
water is also volatile. You can take it. Non-volatile, they won't evaporate, but they will be liquids. Anybody?
Mercury.
Mercury, very good. Yeah, that's all. Lubricant oils. Nivedan, is it right or wrong? Lubricating oils. Yes. Lubricating oils will evaporate or not? No, very slow. Okay. Next, glycerin. Glycerin theruma. Glycerin, more denser than water. Next, have you all know mustard oil? Mustard oil theruma. These all are what? Non-volatile. Because, of course, they are fluids, liquids. But their density is what? More or less. Everybody. Now tell me, lubricant oil, glycerin, mustard oil.
More
High density or low
density.
density?
More density.
Low density or high density? Everybody.
More
More
density.
density. More density means less volatile or more volatile?
Less
Less
volatile.
volatile.
Less volatile. Density is more, less volatile. Density is less, more volatile. Understand, guys? Understand or not?
Yes, sir.
Yes, that is. Now, yeah, coconut oil is less density, but coconut oil is also, it will take, of course, it will be volatile substance you can write. But mustard oil, I'm taking. lubricant oils and mustard oils. So now you tell me, solids and liquids and gases can diffuse into liquids. Is it right or wrong? One liquid can be diffused into another liquid. Solid also can diffuse into liquid, and gas also can diffuse into liquid. Already Mr. Sanjay told, sir, nitrogen, oxygen, this all, we can say they will be diffusing into the water. So into the water, liquids. So is it right? Yes. So now somebody is asking, sir, honey is a volatile or not? Honey is also high density. So it is also non-volatile, almost. Very slowly it will take place. Okay, ma? That is what. So we can say solids also will diffuse into liquids. Liquids also diffuses into liquids, and gases also can diffuse into liquids. So that is what you have to remember it. So let us discuss examples, all of you. Now, diffusion of solids into liquids. So what is our substances now? Today we are studying what? Everybody. Liquids or solids? Liquids. Understanding? So we are discussing now diffusion of solid in where, guys? Respond. Diffusion of solid in liquid.
Liquids.
So for example, so many examples we can make it. So in our surroundings also. So how many of you know copper sulfate? Have you know copper sulfate? Formula is CuSO4. What is the formula of copper sulfate? All of you? Copper sulfate formula is
CuSO4.
Now, if I take a water, if I take a glass of water and I'll put this copper sulfate into this. Now, is it will dissolve or not? Everybody, it will dissolve or not? All of you. Please respond, guys. All of you. Let me take this is cold water. And one more beaker, I'll put hot water. Now tell me in which beaker it will dissolve faster? Hot water or cold
Hot
water?
water will dissolve faster.
Yes?
Hot
Put
water.
5 grams
Hot
of
water.
hot water. Because here kinetic energy is what? More or less? More. Clear?
More.
So copper sulfate dissolves more quickly in hot water than in cold water. So that I can say rate of diffusion increases with what? Anybody can tell me. Solids diffusing into liquids. Rate of diffusion increases with what? Please respond. Rate of diffusion increases with what? Increases in. Yes, please.
Temperature.
Increases in temperature. Is it okay? Lingesh, Pranav?
Yes.
That is what. So this is the example. You can take sugar also. Sugar is dissolved in water. Normal water and hot water. Where it will dissolve faster? Everybody.
Hot water.
Hot water.
That is what. Next. Diffusion of liquids in liquids. Diffusion of liquids in liquids. Can you tell me? This is the most common thing which we people will hate, but so many people will love to do this one. Example. Anybody? Liquids in liquids. Of course, so many. Yes. Recently, Mr. Sanjay has been affected with some kind of health problem because of he has been consumed something like drink from outside normal like street hotel or something. That is what sarbat. Is it right, Mr. Sanjay? You had sarbat and so that your stomach is a little disturbed because of that. Correct? So now, if you notice it, if you are preparing the sarbat or the drink, they will mix the sarbat and other kind of liquids and all into the water. Is it right or wrong, everybody? Yes, please.
sir.
Yes,
sir.
that is what. So that is what you should understand. So now also you can see diffusion of liquids in liquids. Most popular one. Alcohol mixing with water. So many drinkers, when before drinking the alcohol, they will mix the water. Have you all seen them? Anybody? Is it right or wrong? All of you. So alcohol is also a liquid, water is also a liquid. Both are mixing or not? Please respond. Both are mixing or not? Yes, please.
Yes, sir.
Yes. So that is also I can say example for diffusion of liquids in liquids. Clear? So I can say liquid diffuses easily in another liquid. Write it. Liquid diffuses easily in another liquid like alcohol in water. Ellame okayva? And you tell me. Now, for example, I will give you two examples or two things like two beakers to Mr. Kishore. One beaker is having honey. Endara Kishore? Engerika? honey, another beaker is having water. Now you tell me, if I drop one drop of ink, drop a ink. Okay, here also drop a ink. Now tell me where the rate of diffusion is more faster, honey or
Water.
water?
Water.
Water.
You think and tell me. Water or honey? Water.
Water, sir.
Water. Why means
Water.
particles were fastly moving. Water or honey?
Water.
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 So, more greater the fastness. Particles are moving more so that the diffusion rate is more. Is it okay, guys? Everybody? Yes, please. So from that I can say rate of diffusion is different for different liquids or same? Everything. Everybody. Rate of diffusion. Please respond. Different for different liquids or same? Rate of diffusion is
Different.
different for different liquids.
liquids.
Understand, Mr. Sam, Kishore, Gokul Ras? That is what. So example, so where it is diffusion rate is faster. Diffusion is faster in where? Water or honey? Diffusion
Water.
is faster in water than whom, guys?
Honey.
Honey. What is the reason? Because honey is more thicker liquid or less thicker? Less thicker.
More thicker.
More thicker.
More thick.
Understanding? So more slowly than ink in water, as honey is more and more thicker. Understanding? So more thicker, the diffusion rate is decreases. Less thicker, more faster. So we can say that diffusion in liquids also depend on the thickness of the liquid. The thickness only called some property. What is that called as? Here less
Viscosity.
thickness. Yes, very good, Nivedan. So here less thickness and here more thicker. So that property, thickness only we used to call something. Everybody, what we used to call? Thickness is
Viscosity.
only called as viscosity. So now higher the viscosity, rate of diffusion will be less or more? Higher the viscosity. Everybody, higher the viscosity, rate of diffusion is less or more? Higher the
Less.
viscosity, less. Okay, so please write it. So higher the viscosity of a liquid, less will be the rate of
Diffusion.
diffusion. But rate of diffusion is faster than what? Faster than solids. Is it okay, guys? Everybody? Yes, that is what. Next, third one. Diffusion in what? Last property. Sorry, last one. Diffusion of gases in
Yeah.
liquids. That is what you have to remember. Now, so some gases will dissolve in liquids. For example, water, how the aquatic animals will breathe, because some gases is dissolved in that. What is the gases dissolved in it? We all know.
Oxygen.
Oxygen, carbon dioxide, and etc. So that is what. So okay. So some gases, of course. How many of you had cool drink? Have you all had cool drink? Thumbs up, Pepsi.
Yes, sir.
Yeah, if you open the cap fastly, that fluid will come outside. Have you noticed that bush sound will come? That all we used to call as carbon dioxide. Yes or no, guys? Carbonated drinks.
Yes,
Drinks. Gas will come out or not? Everybody? Yes, please. That is what it is.
Yes,
So
sir.
we can say gases will dissolve in liquids or not? Gases
Yes,
dissolve
sir.
liquids or not? That is
Yes,
what.
sir.
Okay. So some gases dissolve in liquids. So what is the example? Carbon dioxide dissolved in which drinks? Example, cool drinks, carbonated drinks. Okay. Carbon dioxide. What is the formula of carbon dioxide? CO2. Clear? Dissolves in cool drinks. Dissolve in cool drink. And oxygen dissolve in where? Oxygen, just now I told. Sanjay also told that. Oxygen dissolves in
Water.
water. Okay, that is what you have to remember. Is it okay, guys? Everybody? So this is what you have to remember it. Any doubt? Okay. Now, so one fact I will say you. So if I take, for example, This is the matter. What is this? I used to call it as what? Matter. Matter means two things. Must occupy space and having what? It must
Mass
have
and volume.
space. If you remember that, it is assumed that ordinary matter, if you consider, suppose this is the matter, it consists of almost 99.99 percentage of empty space only. Okay, so if you take any kind of ordinary matter, understanding generally matter, if you take, it consists of almost entirely 99.99% of empty space only. Then the matter which is present is just 0.001. That's all. Okay, so just for known, that's all. Next one more thing. Now, have you all noticed it? Nitrogen, basically at general temperature, at room temperature, nitrogen, what is the state of nitrogen? Mr. Lingesh? Yes, Sanjay, Pranav, what is the state of nitrogen when it is in general room temperature? At room temperature, what is the state of nitrogen? It will be in a gaseous state. Is it right or wrong? Everybody? Yes, all of you. Now, if you want a solid, okay, nitrogen gas becomes liquid. Okay, if you want to make it into liquid, you have to reduce the temperature minus 196 degrees Celsius. Of course, second chapter we will do it. Okay. So, yes, minus 196 degrees Celsius. Understanding? So this liquid nitrogen we will use to freeze, and we will use it as a delicate material and food items instantly. Okay, use it to freeze the delicate materials and food items instantly, because nitrogen is like unreactive gas. So we will make the liquid nitrogen by reducing the temperature minus 196 degrees Celsius, and we will use science in life, it is use it to freeze delicate materials, okay, and as well as food items instantly. So like you can see, how many of you knows, of course I'm not saying liquid nitrogen, how many of you eat the lace, like a lace packet? Teriyuma lace packet, lace chips and all? Please respond. Different things
Yes,
you all.
sir.
So if you know,
Yes, sir.
if you cut
Yes,
any
yes.
one end of the lace packet, immediately you will get a lot of air outside. Is it right or wrong, everybody? Some air is coming outside. That air is not actually air. What actually it is? It is actually nitrogen.
Nitrogen.
Understanding? Why means because of this lace, the chips and all is actually prepared with the oil. Understanding? Oil and potato, most probably. Please mute yourself. Oil and potato. Now, if you notice it, this oil actually it contains unsaturated fats. Unsaturated fats. So they will react with oxygen. Understanding? So that oxidized reaction will take place. They will be react with oxygen and they'll become oxidation. So once oxidation takes place, the food taste will change. So we people cannot eat that chips. That is why when they are packing, they'll fill with what? Unreactive gas. So what is that unreactive gas called as? All of you.
Nitrogen gas.
Understand? So that is what is important. So this is all about the properties of liquids. I hope you all understand very clearly. Now till here you all people read in our textbook also. Then in tomorrow's class we'll study what is the gaseous state and properties of gas, and then fourth state of matter, plasma, and as well as fifth state of matter, Bose-Einstein condensation. So within 2 days, I think hardly we people will finish this measurement of temperature also. Once that is over, half of the chapter is completed. Then the interconversion states of matter. Interconversion states of matter. Till now, we not studied 5 pages. So 5 gaseous state is over. Then tomorrow it will be almost 5 states over. Then only we are going for interconversion states of matter. And then we are going to discuss what is the effect of change in temperature and what is the effect of change in pressure. Okay, and then evaporation and characteristics of evaporation and how to change the, okay, how to change the like causes of a rate of evaporation and all. So this all we people will discuss in the coming classes. Okay. So now you can see all of you till here in page number 5, first 5 pages till properties of gases. All of you should read and you have to complete it by tomorrow. Is it okay, guys? Will you all follow it or not? Everybody?
Yes, sir.
Yeah.
Yes, sir.
Please
Yes, sir.
complete it and then from
Yes,
there
sir.
we'll continue in the next class. Thank you, everybody.